Understanding IP networks. One of the IP technology main attractions is its ability to handle any video and audio technology. IP brings with it the so-called IP LAN/WAN convergence, which makes it easier to achieve savings and increased flexibility by sharing equipment, studios, control rooms, and production staff across locations. Many broadcasters misguidedly turn to poorly informed IP switch vendors for advice to accommodate the specific needs of broadcasting. While the initial focus should be on getting the network architecture and the control right via any of the three main architecture layouts. Centralized star network. Spine leaf architecture. Dual star. Centralized star network. The tendency for most broadcasters is to adopt what is known as a centralized star network with all connections transiting through a large IP router that can be located in the master control room. It is unsuitable for treating remote locations as extensions of the main location. The main disadvantage is that it requires expensive fiber connections with every single device, while the cost per port for low bandwidth devices is high. Scalability is another problem. Capacity is often reached sooner than anticipated, meaning replacement of the central router. Moreover, lack of aggregation means redundancy needs to be handled by edge devices. Spine leaf. The second model is spine leaf architecture, involving two or more routers at the core, spine, and other smaller routers at the edge, leaf. This reduces the number of connections going directly to the main routers, leading to simplified fiber management. It requires fewer ports on the central router, S, and delivers more effective cost per port, especially for low bandwidth devices. It provides optimal flexibility and scalability, since capacity can be added over time. Dual star. The dual star architecture involves the use of two spine routers, but each leaf in the network is only connected to one spine. This is not a flexible approach when it comes to load distribution and optimization of total network capacity. It puts special requirements on end devices that need redundant connections when the network evolves. The proponents of this architecture usually favor automatic protocol-based routing rather than software-defined networking. Only a true spine leaf architecture enables broadcasters to get the most out of their IP infrastructure investment in their facilities. Automatic routing. Automatic routing means leaving the decision about how to transport individual media flows to the network, rather than the operator. It is used widely in IP networks across the world, but may not be fast enough for live production and can run into trouble with network loops. This can only be fixed through higher operational complexity. On top of this, there are also concerns around protection and security, as streams to destinations are not explicitly controlled. Software-defined network, SDN, routing. SDN puts routing control in the hands of a centralized control layer, creating truly flexible, scalable, and high-performance IP media networks. The management and orchestration software holds a complete view of the available equipment, the network infrastructure and the services. This enables it to make intelligent decisions on routing and controlling flows. This has many advantages. 1. It guarantees a higher level of performance when compared with automatic routing, since the software is also in control of every media flow. 2. It is beneficial from a protection and security perspective by fully controlling which destination is allowed to receive which multicast. 3. It can, with the right software, easily handle any network architecture. However, broadcasters should bear in mind that a successful IP infrastructure is built around the ground-up design of infrastructure. Broadcasters should be architecting the most effective network using a true spine leaf model, and controlling the elements within it using SDN routing.